Hey everyone, in this video, we're going to continue talking about the functional groups, but we're going to focus specifically on ethers and thiols in this video. So let's start with thiols. A thiol is a molecule that contains an SH group, known as a thiol group. Most thiols are extremely stinky. They have really pungent smells, and most of the bad smells that you're familiar with in life are attributable to different thiol-based molecules. Things like really stinky cheese, onions, garlic, oysters, skunk spray, certain marijuana smells. They produce thiol compounds, and that's what gives these things those distinctive odors. Not all of them are that bad, but some of them can be really bad. It just depends on the specific thiol, but they're all typically really pungent smells. And so here's the molecule that's responsible for skunk spray. You don't need to know the exact structure. This is just an example, but it's actually an alkene and a thiol in the same molecule. Here's the compounds responsible for onions, garlic, and oysters and Gouda cheese. So just some examples of thiols you see in everyday life. And actually, we use a certain thiol as an additive to natural gas. So if you accidentally leave the gas on in your kitchen and you can smell it, it's not actually the gas that you're smelling. We add a thiol compound into natural gas. That way people can smell when there's a gas leak, because if we didn't put that in there, gas actually has no aroma, and you wouldn't know that there's gas leaking and filling up your house, and it's like a safety hazard. So we purposely put thiol compounds in our natural gas to help us smell it when it's leaking. So that smell of rotten eggs in the gas is actually a thiol. So how do we name these? Well, we name it just like we do the alkanes, like we learned in chapter 11, except we're going to add thiol to the end of the name. And then you're going to give a number where the thiol is attached. So methane with a thiol attached would be methane thiol. 2-carbon chain would be ethane thiol. 4-carbon chain, where it's attached to the second carbon, would be 2-butane thiol. So let's do some practice. Name the following molecules. Well, we're going to number the parent chain here. So 3 carbons. 3 carbons would be propane. And because there's a thiol, we're going to add thiol to the ending. So propane thiol. And the thiol is attached to carbon number 2. So 2-propane thiol. All right, now this next one. Do we want a number from the left or from the right? Well, we want to have the lowest number possible where the thiol is attached. So I'm going to start numbering at the left. 1, 2, 3, 4, 5, 6, 7. And so the prefix for 7 was hept. So this will be heptane. And then because there's the thiol, it's heptane thiol. And we put 3 on front to indicate that the thiol is attached to carbon 3. 3-heptane thiol. All right. And if we're given the name, can we draw the structure? So 3-ethyl 1-octane thiol. So I'm going to start here with the parent chain. Octane is 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. Let's number it just to make sure we didn't screw up. All right. Now, the thiol is at carbon number 1. So coming off of carbon 1 is the SH. And then it tells us that at carbon 3, there's an ethyl. Ethyl group has 2 carbons in a row. So Boom, boom. There's an ethyl group attached to carbon 3. 3 ethyl, 1 octane thiol. Okay, let's move on to ethers. So ethers have an oxygen single bonded to carbons on each side. So it's sort of an oxygen sandwich. Now, oxygen has lone pairs. And because it has lone pairs, those lone pairs repel each other and force the ether into a bent shape. And so similar to water and alcohols, ethers have a kinked or bent molecular shape. And they're slightly polar. So oxygen is more electronegative than carbon. And so this bond has a dipole going that way. And this bond has a dipole going that way. And because of the bent shape, if the dipoles go in this way and the other dipoles go in that way, the net dipole is right up the middle. And so that would be the net dipole of the whole molecule. And this would be partially positive, and the oxygen side would be partially negative. So there's a polarity to ether molecules. So they can kind of mix with water, but not very well, not as well as alcohols. Now, where do we see ethers in the hospital? Well, they are what's used for anesthetics. And so diethyl ether was the main anesthetic used for over 100 years until the 1950s. And then they started developing newer and more effective ones, but they kept the same ether functional group at the core of the molecule. All they did was replace hydrogen atoms with halogen atoms, which reduces the flammability and the volatility. So here are some examples of modern day anesthetics. These are the drugs that they either give you a mask of or give you an IV and it makes you fall asleep before surgery. So they are polyhalogenated ethers. And so you can see the ether in each one of these molecules: carbon, oxygen, carbon, carbon, oxygen, carbon, carbon, oxygen, carbon, carbon, oxygen, carbon. Right. And so the ether functional group is one of the main identifying features of anesthetics. All right, how do we name ethers? So these have a weird naming system. That's the common naming system. It's not IUPAC. And the common naming system is you just name the chain attached to the oxygen atom on each side in alphabetical order. And so here's our ether. On the left side, we have a methyl group. And on the right side, we have a propyl group. So we just list that in alphabetical order, followed by the word ether. So methyl, propyl, ether. All right, and we name these. So we got to look at the carbon chains on both sides of the ether. So on this side here, that's 2 carbons in a row, so that's an ethyl group. On the other side, there's also a 2 carbon chain, so that's also an ethyl group. So if the 2 groups are the same, we say diethyl, and then ether at the end. So diethyl ether. What about this one on the right? That looks to me like a propyl group. It's 3 carbons. And this one over here, 1, 2, 3, 4, that would be a butyl group. And then we want to list these in alphabetical order. So this would be butyl, propyl, ether. Nice and easy. So we will only be doing the common naming system for ethers in this class. Just look at the carbon chains and list each one in alphabetical order. And I won't give you any ethers with substituents. If I ask you to name an ether, it will just be a simple linear chain. So that's it for this video. Thanks for watching. I'll see you in the next one.